Today's lecture will be talking on introduction to metals and its compound. Okay, so in the introduction to metals and its compound, there are some certain basic things you need to understand so that you can understand what actually a metal is. Some of the things you need to understand is a metal an atom? Is a metal an ion? Is a metal an element? Is a metal a compound? Which means you should have known what is the basic thing that has to do with an atom. I can explain what an atom is. Okay? So this question has to be answered. What is an atom? We understand that an atom is the basic particle of an element. And when you talk about an ion, it is when an atom that has gained or loses electron, it forms what? An ion. But now we are going to know what is an element. When we are talking about an element is that substance that cannot be divided into simpler units by any ordinary chemical or physical processes, while a compound is the thing that contains two or more elements chemically what? Combined together. So we can now define a metal as what? An element. And when you talk about an element, we also have to talk about the definition of a metal based on its ionization, on its electropositivity, on its what? Reducing what? Property. When we are talking about ionization simply means when an atom loses an electron, it forms an ion. And for metal, it is an element that reacts by losing the electron. Which means if X represents an element and this represents the number of electrons that can be lost by an element, you are going to have it as positively what? Charged. So this X is an element, and that X is also a metal, because a metal is defined as an element that loses electron or donates electron during the chemical reaction. So based on an ionization, a metal is defined as any substance that ionizes by what? Electron loss. So we have seen the definition of a metal based on what? Ionization. We can also see the definition of a metal based on electropositivity. So when you are talking about electropositivity, you are trying to look at ions that forms positive what? Ion. And based on that metal, a metal is an element that forms positive what? Metals. Which means that a metal is highly what? Electropositive. You can look at some examples like the sodium ion is Na+, which means it is a metal. Lithium ion is what? Li+, it is a metal. When you also have something like magnesium, it is also a metal. You have calcium, it is a metal. You have aluminum, it is a metal. Why do you say that all these things are metallic ion? Because they are electropositive. They form positive what? Ion, or they form cation. So based on electropositivity, a metal is an element that forms positive what? Ion. Okay? You can also define a metal based on the reducing what? Property. Which means you need to understand what is a reducing what? Agent. A reducing agent is a substance that reacts by donating what? Electrons. Example, if I have something like sodium, the mass number is 23, the atomic number is what? 11. It simply means that sodium atom has 11 what? Electrons. The K shell is filled by 2 electrons. The L shell is filled by what? 8 electrons. While the M shell has only what? 1 electron, which means sodium can be written as 281. That's the sodium atom. So when you have the sodium atom and it wants to react, the sodium atom will now lose 1 electron to become what? Na+. Looking at it, Sodium atom will donate what? Electron, which means that sodium is a reducing what? Agent. So any substance that donates electron during reaction is a reducing agent. Metals react by donating what? Electron. Similarly, magnesium can donate 2 electrons to become Mg2+. Calcium can donate 2 electrons to become Ca2+. Aluminium can donate 3 electrons to become what? Al3+, which means they are reducing what? Agent. So based on that, a metal is a good reducing agent. All right, we have seen the definitions of metals based on ionization, based on electropositivity, and based on what? Reducing what? Property. Then we can also move on to talk about the position of what? A metal in the periodic what? Table. We understand that periodic table is a table, both the column and the row, that represent the activity of what? Elements. In the periodic table, metals are located in the left side of the word periodic word table. In the periodic table, metals are located on the left side of the word periodic word table. We have the left side, we have the middle side, and we have the word right side. Are you get what I'm saying? You have the left side, you have the word middle side, and you have the word right side. Let's look at the periodic table. The periodic table is a table that has the row and the word column. So if this is like a periodic table, you have the left, you have the middle, and you have the word the right side. On the left side of the periodic table, you are going to have what? Metals. On the right side of the periodic table, you are going to have what? Non-metals. Between the metals and the non-metals, you are going to have what we call the word metalloid. On the position of the periodic table, the metals are located on the left side of the word periodic word table. That is why you can have lithium, you can have sodium, you can have potassium, you can have beryllium, you can have what? Magnesium, you can have what? Calcium. All these elements are metals, and based on the periodic table, they are located on the left side of the word periodic word table. Now we can also see metals based on the word valency. When we are talking about valency, we are talking about one, you can talk about the combining power of an element. You can also talk about the number of electrons that occupy the most or the outermost what? Orbitals. Like I can have an example, something like lithium. It has 3 electrons. The first 2 occupy the K shell and the only one occupy the what? L shell. How many electrons occupy the L shell? It is what? 1. And that 1 electron is going to be called the valency of what? Lithium. So you see that lithium has only 1 electron. If you talk about magnesium, which has 12 electrons, 2 will occupy the K, 8 will occupy the what? L. Okay? And 2 will occupy the what? M. The atmosphere has 2 electrons. And because it has 2 what? Electrons, the valency of what? Magnesium is what? 2. So based on the valency, you are going to see that 1 is few, 2 is few, 3 is also few. Something like 5, 6, and 7 is what? Many. Based on valency, metals have few valency. So any element that has few valency is called a metal. So based on valency, metals have few valency. Okay? Then we are still going to discuss the physical properties of metals. When you are talking about the physical properties, you are talking about the properties that are what? Reversible, easily reversible, and in which new substances are what? In which no new substances are what? Formed. In the physical properties, you are going to discuss melting point, you are going to discuss boiling point, you are going to discuss malleability, you are going to discuss ductility, sonorous, hardness, strength, and etc. So we are going to take them one after the other. When you talk about malleability, what is malleability? Malleability is the ability of a substance to be hammered into what? Sheet. So when you have a metal, you can hammer a metal into sheet. But when you have something like clay, it is not a metal. Once you strike a hammer on it, it will split into pieces, which means that clay is not a metal. But metals can be what? Hammered into what? Sheet. And hammering into sheet is what you call what? Malleability, which means that metals are malleable. Okay? We can also talk about sonorous. When you are talking about sonorous, we are talking about producing sound when you do what? Strike a substance. Okay? When you strike a substance like a metal, it produces what? Sound. Metals are what? Sonorous. You can also talk about ductility, which is trying to draw it into what? Wire. You can have copper wire, you can have aluminum wire. Metals are what? Ductile. They have ability to be drawn into wire. You talk about hardness and strength. You talk about what? Hardness and the word strength. Metals are hard, but they are not what? Brittle. Metals are hard, but they are not what? Brittle. When you talk about something that is brittle, something like glass, when you strike it, it will shatter. But metals, when you strike it, it will still retain that hardness. It will not split into pieces. Metals are what? Hard, but not brittle. Okay? You talk about the melting point, which is the temperature in which the solid will turn into what? Liquid. Metals have high melting point, which means it requires a lot of heat to break the solid metal for you to turn into what? Liquid metal at the same what? Temperature. So for metals, they normally have high melting point. And when you talk about the boiling point, which is the temperature in which a liquid will turn into what? Gas or vapor. It requires also very high temperature for you to convert the liquid metal into the what? Gaseous what? Metal. So metals have also high boiling point. You can also talk about the conductivity, which is the ability of an element or a substance to carry heat or electricity. Because of the free mobile electrons in the metals, they are able to convey and carry heat and electricity in their structure, which means that metals are good conductors of electricity and what? Heat. Okay? So these are some of the physical properties. There are other physical properties like we've discussed the malleability, the sonorous, the ductility, the hardness and strength, the melting point, the boiling point, the conductivity. Okay, so these are some of the physical properties of what? Metals. Are you getting what I'm saying? So with these physical properties, we can also discuss